Course 3, Lesson 55, we are looking at nets of prisms and cylinders, pyramids, and cones. So being able to go back and forth between the net of a solid and the solid itself. So, to start off, if we look at this shape, we have a rectangular prism, which means we are going to have to create a net for this shape. So in order to do that, I always like to look at the base and see what is the base of the shape. And in this case, we have a square. And from each of the sides of the square, if you were to unfold it, we would see that we have triangles on each side. So this would be a cut it out, fold it up, and if we are given a net, this is actually a cylinder. Okay, you can see we have our two circles for the top and bottom of our cylinder connected with a rectangle, kind of like a label around a soup can. So if we have the formula for surface area for this, well, typically when we think about surface area, we are saying 2 times the area of the base plus the perimeter times the height. And if we look at this, 2 times the area of the base, well, the area of the base is a circle, which is pi r squared. So we have 2 of them, 2 pi r squared. And then if we look at the side length here, we have h, which is exactly what we have. But then we want to think about the perimeter. Well, the perimeter of the base here is a circle, so we have the circumference, which we can show as 2 pi r. So this length up here is actually the circumference of the circle. And that's where we get our surface area formula. Sketching for this triangular prism. Once again, I look at the base of these and we have a triangle, another triangle, but before I draw the other triangle, I'm going to look at all of the rectangles that then connect them together. We actually have 3 rectangles and another triangle. Now there's lots of ways to draw this one. We could do it like I drew in the first one, or we could have our 3 rectangles, draw them both in the middle, or really any combination where I have one triangle on one side of all of the rectangles, one triangle on the next. Sketch the front, top, and side views of this rectangular prism. Then sketch a net for the figure with labels for top, bottom, front, back, left, and right. So if we do this, if we were to sketch, let's see, they want us to do the front first. Well, I would consider this the front. So our front view would just be that small rectangle that is 5 by 6. Because if we were to look this straight on the front, that's all that we would see. The top view is a longer rectangle where we would say this is 6 and this is 12. We're looking at a bird's eye view of this, so long top rectangle. And a side view is going to be also long and thin, but in this case I have 12 by 5. I can see the height of this figure and the length of it. Now these help us to sketch our net for this. There's a lot of ways to sketch this net, but the big things are that we have 4 long rectangles. Okay, each of those rectangles, let's see, we have the length is 12, and then for a couple of them we have by 5, by 6, by 5, by 6, because those alternate between being based on the height and based on the width of this. And then we have 2 smaller rectangles, which I can put one on one side wherever you want and one on the other side. And these are going to be 5 by 6, and we have 6 by 5. Okay? Which means we can label all of these top, bottom, front, back, left, and right. So we could say this is the front, this is the back. Okay, if we say this is the front, this is the back, then this is the bottom. Okay, so connected there, 6 by 5, this is the bottom. So if that's the bottom, we could say this is the, we can kind of like fold it up. So this is the left. Okay, so this side right here. This would have to be the right, and this would be the top. Okay? And we have a similar one that you can try as well. Sketch the top, back, and right side views of this triangular prism, and sketch the net and label the dimensions. So you can try that one out on your own, folding that out and creating and adding the dimensions. Now, one last thing, and I'm just going to let you do this on your own, but we can also sketch a net of the cone in a couple different ways. Our first way is using paper to see the net of this. So first, we would draw a circle with a radius of at least 2 inches. Okay, we would cut out that circle and then also cut the radius. Once you do this, you're able to kind of pull those two edges so that they're starting to overlap, and what you end up doing is starting to create a cone without a base. Looks like a party hat. Okay, once you do that, to make the circular base, you can do it in one of two ways. You can trace it on your piece of paper, or you can measure the diameter and use the compass to draw the circle with that same diameter. Okay, and then cut out the circle and tape it in place. Now we can disassemble the cone to form a net. You can open the cone by cutting the circular base free on one side, just one side because you still want it attached, and unroll the lateral surface area by making a straight cut to the point of the cone. It's important not to just undo your glue or tape here, because you want to see, all right, when we make our cone, how much of the area do we have? Okay, it's not going to be a full circle. So you just cut up into the peak of that cone. And the net of the cone has two parts. It has its circular base, and we have a sector of the circle that forms the lateral surface area. Now there's another way to calculate the area of the lateral surface area. It's calculating the area of the portion of the circle represented by the net of the lateral surface area. So I'm just reading off these directions. Use a protractor to measure this central angle of the lateral surface area cone you created. The measure of that angle is a fraction of 360. Okay, this fraction, the central angle over 360. So you find the area of the entire circle with that radius, and then take just this fraction of it, and you'll find the lateral surface area. Okay? Well, I hope this is helpful for your homework and for studying.